Agunisha Akorjim. My name is Paul Cunningham and welcome back to the fifth and final day of IST-Africa 2022. We're now in our second eAgriculture session where we have presentations from Uganda, Kenya, Ghana and Mauritius. Our first presentation is focused on data product model for boosting agricultural productivity in Sub-Saharan Africa.
Data product model for boosting agricultural productivity in Sub-Saharan Africa, a research work by Chinecherem, Umezuruike, Chukwemeka Diji, John Patrick Casseem, Habiba Njeri Ngugi. Thank you for this opportunity to present our research work. Eradication of extreme poverty and hunger was a challenge identified by United Nations Assembly in 2000, and it was made a Millennium Developmental Goal. In 2014, the United Nations Open Working Group identified ending hunger, achieving food security, and improving nutrition, and promoting sustainable agriculture as a challenge, and it was made a Sustainable Developmental Goal in 2014 and approved by United Nations Assembly in 2015. Agriculture is a bedrock of the food chain. And in every interaction within the environment by man in the area of agricultural production, data is generated. This enormous data generated is directly from the farmers, whom we call the smallholder farmers, or the remote sensors in the area of embedded technology into agricultural production using Internet of Things. And there is a gap of proper processing, proper use of this data to improve agricultural production. Looking at the challenges of food security, we are prompted by this to go into this research and proposing a data product model that we used to develop data products that will enhance or boost agricultural production in Sub-Saharan Africa. Data products are tools that uses data for decision making and for enhancing agricultural processes. And these tools can be categorized into data as service. When these products generate direct revenue, they can be categorized as data enhanced products when these products are used to build artifacts, and it can be also be categorized as data as an insight when these products developed are used to improve yield. In carrying out this research, there is an objective. The main objective of this research is to propose an implementable agricultural data product that will enhance or boost agricultural production in Sub-Saharan Africa. The specific objectives are to analyze existing data products and to design an implementable model using the universal modeling language. In analyzing the existing data product, we checked reports from the internet, and we noticed that most data that are generated are stocked up in repositories or used for specific research, and enormous data produced are not utilized, they are discarded, stocked up in repositories where they are not available for use for data products. Further processing is needed to make this data useful and to boost agricultural production in Sub-Saharan Africa. The object-oriented analysis and design methodology was adopted. This was adopted because of its well-defined framework that supports design and implementation of complex real-world projects. In the design, we reviewed the objectives. When we are reviewing the objectives, we are reviewing the objectives based on the scope of the project We also got our information from primary sources by interviewing the farmers within our environment locality, and also observation. We also got some of our data from secondary sources, from journals, from the internet, and from some databases. These data we collected form input for an object-based use case and a sequence diagram. At this level, the designed data product will be useful to artifact developers who can develop these artifacts either as softwares for management of agricultural facilities, management of environmental elements that affects agricultural production, and also as hardwares like robots that we use directly in agricultural production and in agricultural harvesting of products, also in planting of products, in management of the animals and management of diseases. When fully developed, the products will be useful to policymakers, agriculture extension workers, smallholder farmers, and the government at large. The iterative model, which shows here as the use case, has 5 human actors, which are associated with different actions, and these actions have included actions. The data producer is associated with data generation. The data product team is associated with data collection, data processing, data implementation, data product and deployment, and maintenance. The farmer is associated with data generation and is also associated with the product. The policymakers are associated, and the extension officers are associated with the products. The sequence at every stage of development, the developer generates the data, which is collected and deposited and loaded into a database. At this database, we have structured, unstructured, and semi-structured data, which might not be useful, completely useful to the data team. Because of that, a mining component is inbuilt into the system, which extracts, transforms this data, and loads them to a database within the component that can be accessed by the data team for further processing. During this processing, a data product will be the output. It follows a 4-step cycle where there is experimentation, implementation, deployment, and monitoring. And this is loaded into the data mart. The data mart, as we all know, is a small data warehouse that is focused within a line of business or a single subject. In this case, agricultural data product. These data products are loaded into the data mart that can be accessed through request by the client, and the clients can be extension workers, policymakers, as the case may be. The clients make a request, the request is accepted either by paying a token or by registration, and these products are made available, which are retrieved and used by the client. The major output or the main result of this research is the data product model. The data product model consists of 5 components: the data product to generation component, the database component, extra transform load component, data product production component, and the data mart. This shows the components, the way they interact with each other, and it ends up with the data mart. In conclusion, the paper proposes a model for an agricultural data product. The data product uses the enormous data generated by smallholder farmers and technological devices and applications as an input to build the data product. For greater research collaborations between Africa and Europe. It will be of importance to note that Sub-Saharan Africa generates enormous non-used agricultural data that can be tapped into, utilized to produce quality food products that can be acceptable and accessible at cheaper rate. As a way forward to further this research work, a team have been identified to implement this research work and develop data products for plant and animal disease management. Thank you for your time, and thank you for listening.
Thank you very much. So can you, oh, sorry. Yanzi, or Sheila, I'm sorry. Please go ahead.
Thank you so much, the presenter. I'm just wondering if you try to carve out data needs to implement this kind of technology. Hello.
Chinecherem, can you hear us?
Yeah.
Can you unmute yourself? Oh, great. Please go ahead.
I was thanking the presenter for that powerful presentation. And my question is that, did you try to carry out data needs for this kind of technology you're trying to implement or to suggest? What kind of data will you need from the farmers or from the community? Thank you.
Thank you, Sheila. Yes, we know that in agriculture, there is what we call indigenous knowledge. And most of this indigenous knowledge are utilized by farmers for either disease management, production of farming, and also in management of animals. So sometimes you find out that this knowledge dies with the individual farmers, which we call the smallholder farmers. So we are looking at having access to these farmers by directly interacting with them, getting this information, and trying to load them into a database where it can be accessed by a data team for specific crops, specific animals, and specific elements that support or affect agricultural production. Let's take, for example, in citrus management, we notice that there are certain diseases that affect them. And with our interaction with some of the farmers, instead of using chemicals to manage this particular disease, they use ash from wood. This ash is being put into water for 3 days, and it is used to spray the citrus tree. Before you know what is happening, this disease is eradicated within a period of 6 months. So this knowledge has been stocked with individual farmers, and we're able to get that. And when we have this, we'll find out that we will not be going to experimentation by identifying from farmers, because we can't work alone. We are going to work with a lot of farmers that are dealing with a particular agricultural product. Then we learn what they are doing. Then the team will now come up with a data product. This data product will be made available especially to extension workers because of the level of interaction and the level of education of most of these farmers. They need somebody that will come down to their level to explain. That is why these extension workers will be of key importance to dissemination of this product.
Thanks, Chinecherem.
Thank you.
Mawaru, you have a question.
Okay, thank you. My question is, you apply your model to a particular data set, say, just to test it, say like data from potatoes or from a certain field, or how is your model so general that you think it will apply to all agricultural products?
Thank you so much for the question. For now, we just propose this model identifying the 5 components. The next thing is to identify the data stream, which we have already done using some postgraduate students as members of the data team in Kampala International University. So this data team will now look at what are the major products that are universal. Let's take, for example, tomato is a universal product, and tomato is uses almost the same level of nutrients in all the locations where it is cultivated. So we will now set it a product after another, because we cannot go into all the products at the same time. So the data team will come up with products for a particular product. We disseminate the information, make sure it gets to whoever and whoever needs them, and they are implemented, they are tried, and if it is successful, we now put it in the data mart. If it is not successful, we review it. So that at every point in time in Sub-Saharan Africa, that product can be managed, that product can be cultivated, that agricultural product can be cultivated to serve a purpose, eradication of hunger. Thank you.
Okay, thank you.
Thank you very much. I don't see any other questions or comments, so thank you very much for that. Our next presentation by Jackson is on Internet of Things, Big Data Analytics and Deep Learning for Sustainable Precision Agriculture.
Good morning or afternoon to everyone. I'm Jackson Machii from Technical University of Kenya, and Professor Eli Choi Misheni and Dr. Julius Murumba are my co-authors. We have the honor of presenting this paper entitled Internet of Things, Big Data Analytics and Deep Learning for Sustainable Precision of Agriculture. And because of population growth, climate change, and food security concerns, agriculture is actually undergoing a digital transformation. However, information technology has an impact on agriculture in terms of cost reductions, efficiency, and sustainability. And also, precision agriculture makes use of Internet of Things, deep learning, predictive analytics, and AI-based technologies. And this research will look at precision agriculture, application areas, the critical success factors, and finally, it is critical to comprehend the advantages of research to individual farmers, the government, the academicians, and the agricultural authorities. Motivations and problem area. We all know that agriculture contributes significantly to the global economy, and farming also contributes to global socio-economic activity. And today, both agricultural research and industry are aiming for long-term agricultural productivity, while also addressing societal needs in data acquisition, management, analysis, visualizations, and utilizations in dealing with cross-disciplinary precision agriculture problems. And because of the rising trends in crop demand, as well as rising fertilizer and pesticide prices, there is a greater need for resource-efficient, environmentally friendly agriculture. And precision farming is thus viewed as a long-term solution to the problems of food scarcity and unprofitable farm practices. The research objective. The following research objective guided our study. First is to assess the role of smart technologies and their impact on the sustainability of precision agriculture. Secondly is to assess the applications of IoT data analytics and deep learning in precision agriculture. And finally, to look into the obstacles to the adoption of sustainable precision farming. The research approach and methodology. A literature review was conducted on the study by examining scientific research papers published in journals and conference proceedings. Our paper major outcomes or results. Precision farming is viewed as a long-term solution to the problems of food scarcity and unprofitable farm practices, and is based on production input precisions applied when and where and they are needed to achieve the highest efficient yields. Also, adoptions of IoT big data technologies can have an positive economic impact by making it easier to provide good agricultural practices or services, collect important data, analyze it, and disseminate insights that help farmers make informed and correct decisions about farming practices and management. In addition, deep learning is used in agriculture to enable weather forecasting, plant disease detections, image translations, fruits counting, land classifications, obstacle detections, plant classifications, weed identifications, animal behavior classifications, and yield predictions. Also, pest management, weed control, agricultural product monitoring, storage management, crop disease management, weather forecasting or monitoring, irrigation management, yield predictions, and other common application areas are also discussed in details in the paper. In addition, IoT technologies collect data and send it to data analytics for analysis. Farmers can access this analyzed data using devices like smartphones, and also farmers can then use the data to manage crop varieties, phenotypes, selections, crop performance, soil quality, pH levels, irrigations, and fertilizer application amount. And because of its popularity, IoT can now be used in a variety of applications such as smart homes, smart agriculture, smart city, smart healthcare, smart logistics, smart transport, smart energy, and so on. And significantly, the government must provide a comprehensive assistance to farmers in these regards, such as inputs, subsidies, permits, rates, irrigation facilitations, and training and sensitization for the adoption of modern farming technologies for realization of high yields and productivity. In conclusions, the findings suggest that agricultural technological advancements, new business models, and markets drive significant GDP growth, and that the study recommends the adoptions and optimization of innovations and technologies that will enable precision farming to be sustainable through quality practices and increase productivity, such as the use of mobile devices, faster internet access, low cost and dependable satellites for positioning and imagery, and precision agriculture, optimized agricultural machinery. Finally, the future research should concentrate on the use of appropriate decision support systems in the implementations of precision decisions. And that is the bring us to the end of our presentations. Thank you for having me as a part of your audience. And I welcome any feedback or questions. Thank you.
Thank you very much. You mentioned a wide variety of different application areas, but before we get into that, Moara, do you want to ask your question?
Well, my question was just that, I was listening to that and I was wondering whether there is, some experimental work that has been done, or you're simply just reviewing concepts and defining them. To me, I cannot see, some experimental work related to IoT, or what is the focus?
Jackson, I can see that you're unmuted, but it doesn't seem to have any sound. So can you try responding? Or if you can, for some reason, would you say that in chat, just so we know if there's a problem? And if there is, then we can move on and come back to you.
Hello, hope you're able to hear me.
We can hear you now, thank you.
Okay, thank you so much for this chance and the questions. Regarding our study, in most cases, we didn't actually focus on a given case study, but we are looking on the various studies and mostly on the research area. But it's actually a continuing study because we wanted to have an implementations and see how we can maybe have an app, but especially on the smartphone. So you can see I've mentioned, or we mentioned on the how the farmers can be able to adopt and make use of smartphones in terms of maybe getting this information, actually insights, where now it can be able to help farmers in terms of like timings, in terms of when can they able to apply some specific input, the farming timing practices, yes, and those sort of items. So specifically, we were trying to review on what maybe other studies have actually focused on it, but it's actually a continuing study. We wanted to maybe come up on an app, especially the use of smartphones or actually messages. Yes.
Okay.
Thanks, Jackson. Ambrose, you have a question.
Thank you again, Prof, the presenter, for your wonderful presentation. My question is, can you throw more light on how IoT can be used in agriculture specifically? Because I understand that IT is one of the emerging technologies which is coming up. And indeed, as you said, it is applied in many areas. As you said, in smart energy, smart agriculture, smart waste management, and many others. And specifically in smart waste management, IoT can be used specifically in the waste bin, in the dustbin, where a sensor can be fixed in the waste bin or the dustbin if you want it. And then the sensor is able to send data to the municipal authorities managing the waste, so that vehicles can be sent to specific routes so that they pick the waste on time, minimizing the use of a lot of resources, managing time, even human resources, because when information is sent on time, the decision makers can make right decision to send the right number of staff to pick the waste. So you could throw more light on how IoT can be used in agriculture. Thank you so much, Prof.
Yeah, thank you so much. Thank you so much on the, actually, when you look on the IoT, it has a number of applications, which actually we measure on terms of, especially on the agriculture, but we know actually the impact in terms of agriculture practices on the environment sustainability, or actually impacts on the issues that come in. Like for instance, in terms of overuse of maybe specific pesticides or actually herbicides. So at least if maybe, for example, like in the use of the greenhouse, that's actually mostly in Kenya, they actually use where we can be able to maybe attach maybe some pipes within the soils that can be able to measure the quantity of the pest can be applied, yes, or the herbicides that can be able to be applied. So at some point, to be able to minimize in terms of the also the effects of excessive these chemicals, and at some point in terms of the pollutions. And so I think at least we'll be able to minimize in terms of that wastage and actually minimization of that area. Yes.
Okay, Jackson. If there are no other questions or comments, and I can't see anything else in chat, I'm going to move on. Before we go on to Diane's presentation, Edison had some technical difficulties yesterday. So while his presentation was made yesterday, he was unable to join the session due to networking challenges. So his presentation was on uses of knowledge management systems in the African context, implementation gap, challenges, and prospects. So what I propose to do is to read out some of the questions that were shared by colleagues yesterday. So Martin, when we get to your question, if you want to read out your question, you're more than welcome to do it. So the first question we have for Edison is, what rationale did the participating NGOs provide to explain why none of them had FAQ pages, discussion forums, or directions on how to access different services on their websites? Did this reflect a capacity gap from a technical point of view, or reflect their attitudes towards how their target stakeholder communities consume knowledge? I hand over to Edison. Edison, I can see you're unmuted, but we can't hear you. So can you check that you're not double unmuted? Edison, we still can't hear you. So can you send us a message through chat if you can hear me? I can see that your mic is open, but there's no sound.
You can hear me?
Yes, we can hear you now. Thank you.
You can hear me now?
Yes, we can.
All right, thank you for that. Okay, so thank you for the opportunity, and my apologies for not being able to connect with you yesterday. And so the first question, like you said, was about the challenge that the NGOs are facing when it comes to using digital knowledge management in their NGOs, and take into consideration the fact that they are advocating for knowledge and education. The main challenge that we were discussing, that we came to realize that they're facing is the fact that they're not having a person who is dedicated for developing and improving the online systems. So they would consult a person, let's say, for a given period of time, and after that, they are done. So I see number one is because they're not having the capacity that they can use in developing, improving, and meeting the modern requirements for digital knowledge management. So that one is the main reason, and possibly because when they look at their priorities as NGOs, it's because budget-wise they seem to have other priorities as much as the budget is concerned, rather than hiring someone who can dedicate the time in managing the knowledge management system. So that is the main reason why, as much the response was concerned, they are somehow behind when it comes to using the tools which can enable them to share and manage the knowledge appropriate to their stakeholders. And well, to some NGOs which look to have the capacity, it points to their management, the will of their management to dedicate some fund to improve their systems and to engage a technical team which can enable them to get there to the point of using such systems or tools as expected. So those are the two key issues that I came to realize when I was conducting a discussion with them.
Thanks, Edison. I think it also perhaps reflects to some degree the relative uncertainty for some NGOs of how much income they're going to have in the future. And as you say, they are managing their resources and perhaps deciding to use the resources in other areas, which is understandable if unfortunate. So the second question was, what unexpected or unanticipated results did you identify? What surprised you based on this engagement with NGOs who are focused on education advocacy, where one would have thought that communication would be given a very high value? Thank you.
Okay, thank you for that. As you've said, especially the last part of the question, you would expect that these organizations which are engaging themselves in knowledge advocacy, education advocacy, you would expect them to vigorously engage into the use of information systems for sharing the same. So to me, I was so surprised to see that in these modern tools, most of these NGOs we're hardly engaging in their use. So to me, that was a surprise because I expected, to have a good number of them engaging into the use of these information systems when it comes to managing the knowledge, and since because they are advocating for knowledge. So to me, that was a surprise. To see that they were not, they were completely not engaged. Most of them were completely not engaging to the use of these technological tools in managing knowledge.
Thanks, Edison. And then Martin, if you're online, do you want to ask your question?
Maybe before Martin comes in, Sam.
Please go ahead.
Yeah, maybe before he comes in. There's another element that was brought up in yesterday's discussion about what they can do, and especially what specialists recommend when it comes to the use of these systems. And one of the recommendations that I gave was for NGOs to engage universities which are training students, computer students, IT students, and engage them in their programs, because once in a year they have like 6 months where they are released. These students are released for internship, for practical activities, and they would have access to this knowledge at a very low cost. And I can tell you that most of these students are doing so well when it comes to system development. So the problem of not having someone who is dedicated would somehow be addressed by linking with universities and getting students who are technically advanced and who could help the NGOs to further their agenda when it comes to knowledge management. So I think somehow the strategies for NGOs when it comes to sharing the knowledge, when it comes to getting the right people to enable them, is one of the areas where they're getting challenged.
I think that just reinforces the importance of multi-stakeholder collaboration. I believe that you're correct, that by partnering with the local university that has competency that either complements or is complementary to what they're doing, and understanding the whole environment. And I think that there's a mutual benefit there, because the students can get hands-on experience. The
Yes.
universities have access to real-life projects that will meaningfully impact on the lives of the communities that they support. And
Yes.
obviously the NGOs benefit because they have more competency, and perhaps they can identify future employees. Because
Yes.
if they find a student that's coming up to graduation who's genuinely interested in the work that the NGO is doing, they've
Yes.
experience working with them, and therefore they have a manageable risk in terms of if they have the resources to consider approaching that individual and saying, would you like to work with us full time when you graduate? So I think that's a win-win.
Yeah.
Right, so I'm just going to read out the final question I have from Martin, where he complimented you on the interesting research and findings. And he asked, could it be useful, especially when experts shared lessons on how they overcome challenges encountered, so others could apply what they come across in similar challenges? And on the implementation gap, particularly the lack of artificial intelligence for mining tacit knowledge, which is usually difficult to transfer based on his personal experience. When experienced employees leave the organizations, tacit knowledge is not lost. So in other words, institutional memory. And then he asks, in case your research scope didn't cover it, future research could look into it as it promotes learning in organizations internally. So do you have any comment on that before we conclude?
Well, that's a possibility. Actually, we as professionals, we have the responsibility of sharing the knowledge that we acquire when it comes to, interacting with these NGOs or organizations on how they can pull themselves out. And one of the ways is like now the conference that we are having now. So I know that I'm going to have an opportunity to meet with that collaboration of NGOs, and that's one of the things I can recommend to them, that they can, even when they have their forums, they can bring in experts in the area and see what they can contribute in terms of opinions on how they can advance from where they are. So to me, that is a very good, it's a joining idea. It's a good proposal, and so I'm going to take it forward to the forum.
I think that's great, Edison. I think it's very important that there's very positive engagement going forward. So thank you very much for that. That was very useful. And I'm glad you're able to join us today. I'm sorry you were having technical problems yesterday. So our next, no, my pleasure. So the next presenter in this session on agriculture is Diane, who's going to discuss a regularized multitask neural networks convolutional learning model for maize disease identification.
Good morning, everyone. My name is Diane Niyomwungere. I'm a master's student in information technology at Jomo Kenyatta University of Agriculture and Technology in Kenya. Our topic is about multitask neural networks convolutional learning model for maize disease identification. Other authors are Professor Niyomwungere and Dr. Richard Rimiro. We'll be talking about motivation, objectives, methodology, implementation, results, and conclusion of our research. Motivation. Maize is a staple food for over 90% of Kenyans, according to Untitled. And one of the main challenges that the maize crop faces is the presence of many diseases. Recognizing maize disease and its pathogen helps at preventing the disease spreading throughout the field, as some are spreading very quickly. Consequently, farmers consult experts who are expensive and not always available. Nowadays, new technologies are widely used, especially smartphone and internet. Example, according to SMEs, mobile smartphones are increasingly popular among Kenyans. And through those technologies, machine learning model may help at identifying the disease from image using convolutional neural networks technique. But when building a machine learning model, overfitting may occur. Overfitting means that the model cannot generalize well on previously unseen data. For example, when I provide a new image to a model which represents a virus, the model can recognize it as fungus. So to avoid overfitting, there exist techniques called regularization techniques. And the problem is, which regularization technique is the best for a given model? And another question is how to perform multitasks with one model as a simple convolutional neural network model can only perform one task at a time. In our case, we have the disease and name and pathogen. So to respond to these questions, our main objective is to implement regularized multitasking neural networks, convolutional learning model for maize disease identification, and specifically various regularization techniques are combined and compared for the best performant model, and test the model on previously unseen images. Methodology. The conceptual model used follows the machine learning workflows. And the first step is to gather data, then prepare the data, and train the prepared data to the model, and test the prepared data to evaluate the model, which is tuned to the gathered data. And as there exists two multitask learning architectures, which are hard parameter sharing and soft parameter sharing. And our aim is to take advantage of sharing parameters. However, parameters are not shared between tasks models in soft parameter sharing. So we propose to, we choose to use hard parameter sharing method, which is divided into shared layers and task-specific layers. And feature extraction is done at shared layers, and classification is done at specific layers. Implementation, excuse me. All the experiments were executed in Google Collaboratory, which provides a GPU accelerator and TensorFlow platform with Keras. We use the Keras functional API, which can handle complex models, and Python was the programming language used. The dataset, the original dataset we used in this experimentation consists of 2,636 images with a shape of 224 and 224 with 3 channels, RGB colors, which became 5,077 images after data augmentation. And the dataset includes 5 classes of maize disease and 2 pathogens, fungus and virus. We use rectified linear unit as an activation function for the shared layers. softmax activation function was used for 5 classes of disease classification specific layers, and sigmoid activation function was used for the 2 types of pathogens of disease specific layer. The pooling size is 2:2 for the whole models, and for all the experiment we used Adam optimizer with a running rate of 0.001. Accuracy was the performance matrix in the dataset was split into 8% for training set, 20% for the test set. The validation set is made up of 20% of the training set, and we used a batch size of 32 with 200 epochs. This is a summary of our results from all our experiments. Our first experiment consists of in blue consists of building models with no regularization. We trained the 2 models separately and considered this as our baseline. Our next experiment was to build a multitask learning model which combines the 2 models. The third experiment involved adding an array-stop technique to the multitask learning model with the patience of 10. The fourth and last experiment was about using a pre-trained ResNet 50 model on ImageNet for the feature extraction, as our dataset was not big enough. So the disease name classification model was overfitting for the first experimentation. So it demonstrates constant variation during the 4 experiments. Indeed, the model's test accuracy was 60.89% with no regularization methods. It rose to 74.48% when using the multitask learning technique. And in the third experiment, the test accuracy became 77.74%, which increased to 85.22% by combining multitask learning with array stopping and transfer learning. For the disease type classification, the test accuracy remains almost unchanged. Conclusion. This research proposed a regularized multitask neural networks convolutional learning model. Using multitask learning technique allowed us to build multi-class and binary classification models in one model, identifying maize disease and its pathogen at the same time. Also, using hard parameter sharing architecture allowed feature extraction done at shared layers, which reduces overfitting. In addition, we found that combining different regularization methods is a good technique for best performance. And in our case, combining multitask learning, array stopping, and transfer learning gives us better results. This the lack of sufficient data may explain this. While a significant amount of data is required for the best performance of convolutional neural network. Finding large library dataset remains a challenge in the agriculture field. Following that, future research would focus on training a combination of different regularization methods on more extensive and more diverse dataset with more tasks. In addition, our application was limited to Kenya's most common maize disease. However, maize is consumed in many countries. So future work would consider including more maize disease for maize users. Thank you for your attention.
Thanks, Diane. So can you comment on any field work that you either have undertaken so far to identify how accurate this would be, or how that's planned, and then how you see this as being applicable across other types of crops beyond maize? Thank you.
Can you come again, please?
Of course, Diane. So can you talk to us about any experimental data that you have in terms of using your research in the field, or any field research that you have planned, and how you see what changes or adaptation you would need to do to apply these techniques beyond maize? Thank you. Dan, we can see your mic moving, but you seem to be muted internally. So can you just check that you don't have your speakers turned off?
Maybe I could just comment as Diane tries to come in.
Please, go ahead.
Yeah, because we did this with Diane. The data that has been used here in this study is mainly what we call secondary data. So this is now, it is now from this that we want to actually now go ahead and try and get some data on the ground. So this has not yet gone to the field work. It's simply just used already existing data, and then now try to test, Google Colab, trying to test the theoretical model. But seems to work a little bit, although actually with some restrictions. We now hope to go to the field and do some testing. Thank you.
Thank you very much for clarifying that. So does anybody else have any questions or comments for Diane? And Diane, can you try speaking again if there's anything you want to add to what Wawaru has already shared? Okay, I don't see any other questions and I don't hear anything from Dan, so thank you very much. Then moving on to Daniel's presentation, which is on the design, construction and testing of a cocoa pod breaking machine to improve cocoa processing. Thank you.
Greetings everyone, I'm Daniel Mushi, pursuing a bachelor's degree in electrical engineering at Ashesi University in Ghana. I am interested in electrical machines, renewable energy, industrial control, automation and computer-aided design. I am passionate about using my engineering knowledge to solve problems and make an impact on society. On behalf of my co-author, Dr. Hedabim at Ashesi University, I'm here to present our project on the design, construction, and testing of a cocoa pod breaking machine to improve cocoa processing. Stay tuned and enjoy my presentation. The global demand for cocoa has been on the rise, calling for faster cocoa production and processing techniques. Chocolate, a product made from cocoa, is one of the world's most popular foods. Also, cocoa contains about 50% fat, which is essential in the production of ointment, lightening oil, and medicine. Moreover, the husk is a reliable source of potassium, essential to the production of potash fertilizer, biogas, and local soap. Additionally, the cocoa sector is an important source of livelihood. According to the Global Market Report, cocoa provided revenue for 40 to 50 million people in 2012. These and many more are the motivations for this project. Regardless of the high demand for cocoa, many stages of cocoa production still rely on manual methods. Cocoa pod breaking is a crucial step in cocoa processing, and its over-reliance on manual methods has since remained unaddressed for farmers. This dependence on manual method has been reported to have involved over 2 million children in farm child labor in West Africa, directly impacting their health and education. Competitive labor with other industries is another problem associated with cocoa production, leading to shortage and high cost of labor. Aging farmers is another problem associated with the cocoa industry. The main objective of this project was to design a mechanical system that could address the challenges involved in manual pod breaking. A mechanical system has many advantages it will provide. First, it will reduce child labor. The aim was to design a mechanized machine that would automate cocoa pod breaking and reduce the over 2 million children reported to be involved in farm child labor in West Africa. Next, it will reduce labor requirement. The extensive labor required for manual processing results in a high production cost due to requisite payment of salaries and wages for workers and supervisors. A cocoa pod breaking and separation machine will reduce labor requirement. Also, the machine will reduce risk and drudgery. A mechanized method of breaking pods will reduce fatigue and any health risk on the farmers and laborers. This innovation may also reposition the cocoa sector as an aspirational one, motivating youth to go into cocoa farming as a profession instead of regarding the breaking of pods as drudgery. Another objective was to improve quality of beans. A cocoa pod breaking machine will improve the quality of beans as it will separate the beans from the husk and placenta and reduce debris in beans. Quality beans gives the best chocolate flavor. By improving the quality of beans, value will be added throughout the chain. Additionally, the machine aims to reduce operation time. A cocoa pod breaking machine can dramatically reduce the operation time required using the manual method. Time saved in pod breaking step can be used to perform other processing steps, thereby increasing production. Finally, it is to reduce losses. The high labor requirement to break cocoa pod causes farmers to abandon their pods in the farm in search of labor, resulting in some beans germinating at the farm and thereby becoming losses. A machine provides available labor and can also carefully break pods with less damages to the beans, reducing the losses. Aside having preliminary knowledge about the challenge, it was essential to undertake a deep engineering research to understand the problem. This research enabled us to review past attempted efforts made to solve this problem and why most have been unsuccessful. This further gave us insight into how we should design ours to overcome the existing design challenges and still solve the problem. For instance, through the existing design review, we discovered one of the first pod breaking machine which was designed by the Cocoa Research Institute of Nigeria. It worked but appeared that this solution was not adopted because it crushed the husk into tiny portions mixed with the wet beans, which made separation challenging. Other challenges associated with other designs was using electricity as source of power. Meanwhile, electricity is not easily accessible in most farms. Also, bulky machine making it difficult to maneuver farm terrains and difficult in mobility. After the thorough design review, the engineering design process such as ideation, conceptualization, design, and development were followed to arrive at building this solution that addresses all our objectives. The design process took into consideration different design concepts, part sizing, force calculations, and availability of materials. The design concept considered factors such as standard size of cocoa pot, maximum force required to crush one pot, engine drive speed, and materials of machine components. Equation 1 and 2 guided the sizing and selection. Equation 3 to 6 also guided the evaluation of the machine performance during the experimental processes. The machine can currently break about 4,800 pots per hour, which is 4 to 5 bags, and this is a marked improvement over the manual method's performance. It has a competitive edge over manual method where a person can break about 600 to 1,200 pots, which is half to full bag depending on the person's expertise within the same 1 hour period. The machine current production rate indicates that the machine saves about 35% per every 10 bags production cost compared to the manual method. The table shows the competitive advantage over other current means of pot breaking, taking into consideration capacity per hour, mobility, user-friendliness, maintenance, and manufacturing process. As the lead author, I have founded a startup called TechSpec to ensure that the design is fully developed and built for commercial production with support from partners like SayTech, which is an agri-tech company that designs and builds smart agricultural machinery suited for African conditions. The manufacturing of the machine would revolutionize the cocoa sector as well as create job opportunities. The success of this machine would actively engage both the formal and informal sector, including but not limited to graduate engineers, local fabricators, material providers, and machine operators. However, delay in acquiring patent has been one of the challenges delaying commercialization. Also, requisite certification from local regulatory bodies is another challenge affecting commercialization. Despite the challenges of commercialization, the machine has an enormous market potential. Africa alone contributes about 70% of the world cocoa production, and Ghana is the second largest producer after Cote d'Ivoire. The total available market for the cocoa industry in Africa is worth $9.46 billion. The serviceable available market, the Ghanaian market, is worth $2.5 billion. And the target for the pilot stage is the Ahafo region in the Asunafo North Corporation, whose addressable market is worth $21.27 million. The machine is considered to have a life expectancy of 7 years with an estimated cost of production of about $1,500 as per the time of analysis. However, per the profit analysis, any owner can recover this cost within first 2 years of operation. In conclusion, as global consumption demand for cocoa increases, pressure is mounting for faster methods of cocoa production. The cocoa pod breaking machine developed can help farmers produce cocoa faster and more conveniently. The machine was developed following a systematic engineering design approach. It was fabricated using locally sourced materials. The machine achieved most of the objectives through the testing. The current iteration of the cocoa pod breaking machine can break about 4,800 pots per hour, which is a production increase of about 4 to 6 times compared to manual method. The machine will create new jobs and serve as lucrative venture for our target market, growing year-on-year demand for cocoa pod breaking services. The solution would also significantly reduce on-farm hazard and child labor. The design is poised to have a significant impact on the cocoa sector of Africa, since such system is to aid cocoa farming, have evaded large-scale adoption. Thank you for listening to my presentation.
Thanks, Daniel. That's a very interesting presentation, especially as you're an undergraduate. So can you, first of all, discuss validating the proposed return on investment to assure farmers or cooperatives with limited resources to take the necessary financial risks associated with investing in a new solution that requires a 2-year return on investment?
Thank you very much, Professor Paul, and thank you to everyone for listening to my presentation. So right now, the key way to assure investors and cocoa farmers is that the design or the whole startup is anticipating to kind of model the whole system in these ways. We would have outreach sales where farmers with enough money can purchase the whole design. And we also have hire purchase. So with this, farmers who don't have enough money to purchase the whole design could hire the machine based on demand. And we could also have pre-orders. And also, depending on the machine operation, there will be repairs and maintenance, which could be source of income back to the main company. And we also have spare parts sales for the maintenance of the machine. We're also anticipating to kind of create a team that would also support people who have purchased the machine. And so these are some of the revenue generating source for the startup. If anyone is ready to invest, there's an assurance that there's enormous generation of revenue fund that can refill the system back. Thank you.
Thanks, Daniel. I like your multi-income stream business model. I think that's very good. However, you have to appreciate how you would sell that to a farmer, because if they start thinking about repairs and maintenance and parts, they're going to start asking you some hard questions. So you need to be prepared to answer those hard questions. I have another issue that I want to raise, and I'm going to put it in chat to give you some time to think about it. And in the meantime, Wareru has a question he'd like to ask.
Okay, so a bit, let me just touch on the repairs and the maintenance aspect before. So basically the engine we are using is an available engine that is already being used by the farmers for other purposes, like grinding mills and then water pumps and other stuff. So it has been found that we have local technicians almost in most parts of the country that can easily handle the repairs of the engine. And so it won't really require technical invitation of our team. But if that is a demand, we could be available to assist. And most of the parts of the machine too doesn't really require technical maintenance. So that wouldn't be much of a challenge for the farmers to handle. Thank you.
No, I appreciate you mentioning that, because it's important if you're planning to scale. If you have people who can maintain it locally, that makes it much more attractive than, oh, it's going to take me a day to get to you, or I don't have somebody free to come to you for 3 weeks. Those are all risks. Whereas if, as you say, you're using a known quantity in terms of an engine that lots of people know how to work on, then that helps you scale your business. So that's good. So Wareru, you're up.
Thank you.
And my question, Daniel, is in the chat as well, okay? Wareru?
Okay, thank you. My question to you, Daniel, is about power. Does the machine use a lot of power, when it is operating? Do you think that it is very power hungry? And related still to power is it possible probably now in the future to get it to use something like a battery? Maybe people could charge it and use it later or something like that? Thank you. Thank you,
sir. So currently the engine is about 5.8 horsepower, and it's a diesel engine that consumes approximately 2 gallons to kind of work for close to 7 to 8 hours. And so it was from that estimation that we were able to calculate and know that it has overcome the manual process by the cost percentage. And so considering it's consuming 2 gallons for 8 hours of operation, that is good enough and not really power hungry. But for future works, more works is being done to see how best we can probably adapt a battery system as you have suggested, and probably some solar panel to cover up some of the external parts so that that could also be a source of power to kind of power the system whilst it is in operation. And so thank you for that recommendation as well.
Thanks, Waru. Daniel, let me just read out the question that I put into chat. You raise an issue which is a challenging one in today's society. The conflicting needs of optimizing family income levels to raise communities out of poverty, the undesirable implications, as I see it, of child labor with the unfortunate social, health and safety and restricted educational opportunity implications for one of the most vulnerable segments of our society, the risks associated with mechanical automation and its social implications in terms of labor and income opportunities, particularly for low-skilled labor, and the importance of investing in skills capacity development to upskill existing low-skilled labor, so as their jobs disappear, they can support their families. So I'd welcome any thoughts you might like to share, and indeed anybody else who'd like to comment on this.
Yeah, thank you. Specifically, I don't know if the question is geared around how if we reinvent the automation, how we can help build the capacity of unskilled farmers. I don't know if that is the question exactly.
Well, I suppose I'm just highlighting that if child labor is no longer needed, I think most people would agree that that's probably a very positive thing in terms of educational opportunities and bringing communities out of poverty. But at the same time, it has the social implication that family members cannot generate as much income for the family as they would have in the past. So that puts more pressure on the parents. So, you know, it can cause a lot of stress. So I suppose what I'm getting at is you need to, and this isn't just your responsibility, this is everyone's responsibility. We need to think through the implications and the lessons learned from previous industrial revolutions where we introduced automation, people lost their jobs in the thousands and millions, and there is no safety net in many African countries today, unlike what there might be in wealthier countries. In other words, there's no social payment if you don't earn income. You just have to find income some other way. So I realize that this is not your problem as an individual, but I believe it's our problem as a knowledge society. So I'd welcome any thoughts you might have in terms of balancing opportunity against responsibility. Thank you.
Okay. Thank you very much. This is really an interesting question. I believe the farmers already are not really making much income from the use of engaging, their children in child labor and other low source of skills labor in the operation. The only thing is that they are taking advantage of the children and other available labor because they don't really have an alternative. So for children, for some farmers, if they plug when it gets to the season of cocoa plugging, there's usually scarcity of labor because we have a lot of people almost plugging at the same time, and they will need laborers to break these pods and all that. And so the farmers tend to rely on their children because if they don't do that, their pods would stay in the farms and then germinate and lose their quality. And so if they have an alternative, I'm pretty sure they will adapt to that, and that would in turn rather improve the source of their income, as if they now rely on the machine, they will be able to break these pots on time and they will be able to break them effectively and rather not take advantage of their children, as that is the only alternative they may have. I think that is the only thought I can think so far on that aspect. And yeah, that's it. Thank you.
Thank you very much, Daniel. A very interesting presentation. I wish you and your colleagues the best of luck. So our final presentation before lunch is from Mohammad, and it's on the design of a tomato harvesting robot for agricultural small and medium-sized enterprises.
Hello guys, I am Shoaib from the University of Mauritius. I recently graduated with a bachelor degree in mechatronics engineering. Today, I'm going to talk to you about my project entitled Design of a Tomato Harvesting Robot for Agricultural Small and Medium Enterprises. Before we dive into the topic, let's first take a look at the table of contents. First, I will start with a problem area. Then I will move to the research objectives. Afterwards, I will give you a detailed explanation about the methodology and the results of the experiments. Finally, I will end with the business benefits and I will give an interesting conclusion that will empower both local entrepreneurs and young engineers. So, what is a problem area? Globalization and the concept of global village, where countries are able to depend on each other, is not something new. However, did you know that its overdependence can have serious impact due to the smallest of disturbances? Yes. Food scarcity is a major problem in small economies such as Mauritius. Luckily, AI can be harnessed to provide support to local entrepreneurs. However, new technologies still pose a barrier in small inland developing states because of the lack of opportunity and support from the local government. What are the research objectives of the project? First and foremost, the project aims at breaking down the barrier between technology and local entrepreneurs. The project also focuses on dealing with the high cost of production and labor scarcity that Mauritius is currently facing in its agricultural sector. Finally, the project aims at providing an affordable and state-of-the-art solution for the autonomous harvest of tomatoes in SMEs. Now, let's move on to the research approach of the project. We started off by defining the problem. Then, we identified the environment in which the system would be used. In our case, tomatoes in Mauritius are best grown in greenhouses. Afterwards, the system to autonomously harvest and move the system around the greenhouse were identified. So, what is the definition of the problem? The problem definition stems from the fact that we need to design a system that can autonomously harvest tomatoes for SMEs. How can that be achieved though? After working on multiple concepts, we came to know that the best way to deal with such problem was to build a robotic arm to harvest the tomatoes, and the whole arm would be mounted on an AGV or automatic guided vehicle if you want to move around the greenhouse. This is a 3D model of the tomato harvesting robot. You can see from here that the arm is mounted on an AGV and there are 2 cameras for detecting the tomatoes. Slots are available to place containers to store the fruits. We will now be looking at the different technologies that are currently being employed by the harvesting robot. First and foremost, we have the camera vision and recognition system. If you are familiar with the concept of computer vision, you might know that we can train or program a system to recognize objects, and in our case, the objects are the tomatoes. We also have the stereo vision technology. What is a stereo vision technology? It is basically a system of 2 cameras where we can visualize a 2D scene to a 3D one, just like our eyes work. Therefore, we can extract the distance or real-world coordinates of the tomatoes, and these coordinates can be transferred to joint space to rotate the arm to pluck the tomatoes via the technology known as inverse kinematics. Because we want our robot to move autonomously around the greenhouse, we have employed a technology known as line following. What is line following? Basically, we stick black lines on the floor of the greenhouse for the AGV to follow them autonomously. As part of my project, I have built a prototype robotic arm. Here, in this slide, I have included some screenshots so that you can have a better glimpse of what is really happening behind the scenes. So, as you can see here, the robotic arm is controlled by servo motors because of the accuracy and precision in moving the arm through the required angles. The base of the robotic arm was controlled using stepper motors. For the stereo vision system, simple webcams were used as a proof of concept. Not top-of-the-line systems were employed here. For grabbing and plucking the tomatoes, a two-fingered gripper was actually used in this scenario. So, what were the results? As you can see here, the system was successful in recognizing and detecting tomatoes. From the picture, you can see that a bounding box was drawn around the frame. How was that achieved? It was achieved using HSV thresholding or hue saturation value thresholding. Basically, it turns everything that cannot be considered as a tomato black. Here you can see the background is fully black. The system was also successful in grabbing the tomato, as you can see from this picture. Having obtained the real-world coordinates from the stereo vision, the inverse kinematics algorithm, which I previously discussed about before, successfully converted the coordinates from the coordinates to the joint space so that the arm could rotate. Business benefits of the autonomous system. The cost for building such system, including labor costs of course, was approximately $4,500. It was found out that the robot could work 4 hours non-stop, and in that period of time, 116 kilograms of tomatoes could be collected. Some 2 years back, the price of tomatoes in Mauritius was approximately $1 per kilo, but now, due to inflation, the price quickly rose to $4 per kilo. With such system, companies can thus expect a gain of massive $464 per day. All in all, we can say that this project was a success. The system provided multiple benefits to SMEs such as consistency in work of operation, compensation for lack of labor, and improvement in well-being of workers. Most importantly, however, this project serves as an inspiration to young engineers who can work and strive for their local economy so that they can bring the country to the next level of industrialization. Thus, a one-stop shop can be set up where researchers and technopreneurs can meet and discuss about the various problems that the economy is currently facing. This mindset, of course, will encourage an innovation culture, which will lead to the further development of the country. This brings us to the end of this presentation. I thank you all for your time, and I will be more than glad to assist you if you have any further questions. Thank you.
Thanks, Mohammad. So first of all, where was the robot field tested under what experimental restraints? And how did this scenario compare to a real-life greenhouse environment? Thanks.
Hello. Can you repeat your question, please?
Of course. Where was the robot field tested and under what experimental restraints? And then how did this scenario compare to a real-life greenhouse environment?
Okay. Unfortunately, the robot wasn't field tested because, because of COVID, we weren't able to build an actual robot. So we built a prototype and tested it in a lab with a small tomato tree. And so we had good results, and we were able to successfully detect the tomatoes like I discussed about. But how did the environment compare to a greenhouse? For the robot to actually work in the greenhouse, we have to set up a system known as an AGV, which is an automatic guided vehicle, which I wasn't able to build, and neither as a prototype nor as a real bot. So further tests need to be done, further experiments need to be done to actually use a robot in-house.
So Waru, you have a question.
Okay. My question is, what kind of sensors does this robot use? Is it on the cameras? And does it rely on internet connection or connectivity?
Okay, the sensors that the robot use actually are cameras, like I've talked about, and also for plucking the tomatoes, we need a force sensor on the gripper to know when to stop pressing on the tomato when plucking. And also we have a system, a sensor known as an infrared to actually move the HV around the greenhouse where it will follow black lines. Whereas actually there are three sensors, the webcams, the force sensor at the gripper, and the infrared sensor. And no, it doesn't rely on an internet connection to work.
Thanks, Waru, for the question. So I think some of my remaining questions you may not be able to answer because of the circumstances that you tested under, but it would be useful for future research.
Yes.
What is the relative performance characteristics of the picking function, which I think goes to Waru's question in terms of the type of sensors that you use and their performance, and whether or not you need a live connection or whether the processing is done on site? And then how does that picking rate compare to an experienced or indeed an inexperienced human being? And critically, how does the robot know whether or not it's premature to pick specific tomatoes? Because that's one of the skills that a human has, is that they can touch the tomato, they can squeeze it, and based on the resistance, they can tell if it's ready to pick or not.
Okay. To actually know when to pick the tomato, it relies on the camera, and it mainly detects the redness of the tomato. It won't rely on the touch to know if it is ready or not. Actually, for the time being, the robot is not able to do that, but it will use a camera, and through thresholding method, it will know if the tomato is ready to be plucked. And that's it.
Okay, and then how would you propose to deal with unexpected objects blocking the robot and indeed the risk of human injury in a real-life greenhouse environment?
To prevent human injury, we have to upgrade the robot to actually meet the standards that are required by robotics, actually meet robotic standards to prevent human injury, but unfortunately it hasn't been implemented yet on the robot. In fact, we will need further sensors known as limit switches or ultrasonic sensors to sense the presence of a human nearby and turn off all the system as an emergency response. But it hasn't been implemented.
I understand. And if I can just clarify, I think you said
Yes.
that the cost of building this was around $4,500. Was that correct?
Yes.
And does that include an estimated cost of the AGV, or that just includes the arm?
It includes the AGV, in fact.
Okay. Right. So, Mohammad, thank you very much indeed for sharing this insight. And it will be very interesting to see what you can do in a real life environment. So, Suman, just a final comment goes to you.
Yes, Suman points out that the precision of selecting the mature tomato will be improved with a multispectral camera. It's true, but it will be much more costly then.
I understand. I just point out that in many environments, commercial farming environments, some tomatoes may actually be picked when they're still green because they're going to be transported and ripened when they get closer to the target market. So this is something you may wish to take into account as you do further work in this area. So thank you very much for an interesting presentation.
Thank you.
So we're now coming up to the lunch break. And we are starting again on the hour. So you have about 45 minutes. And the final session today shares presentations from South Africa and Kenya. So I wish you an enjoyable break, and we look forward to seeing you back in time to start sharp on the hour. Gurmila Mahagat Slangafol.